Alright, let's get started. We're gonna start with some easies. We'll do longest common prefix. Write a function to find the longest common prefix. If there is no common prefix, return empty string. So we go through each string and find the longest prefix of all strings. Yeah, we're going to be doing this in JavaScript. And let's start with a simple solution. Maybe we could figure out a more advanced solution after that. So we'll do for let I equals 0, I is less than strings.length I plus plus. Actually, say I don't know when this will stop, to be honest. Instead, we'll do for let j equals 0, j is less than length j plus plus. And so we're gonna have two loops here. This loop is like track the length of the prefix so far. And so the length of the prefix is 0 so far. And we'll actually start j at 1. And it might be good to get the length of the shortest string in the list. Let's just do this for now, and then we'll think about edge cases. So pretty much what we're going to do is, just for sanity, we'll do strings sub I sub j minus 1. And b is strings at I sub j. And pretty much if a is not equal to b, then we'll return I, because that's no longer, we do I minus 1. We actually had to do string sub 0 dot substring from 0 to this. And at least be 0. And I think we should probably A at, if not A or not B, or A is not equal to B, just in case we go out of bounds of the string. And this one, track the string we are looking at. Alright, so the idea is we're basically gonna go forever. There's always at least one string, and each string is 0 to 1, 0 to 200. and only lowercase English letters. So we basically go through each string and or actually basically go through like each character. We're building up a prefix, and for each string we compare it to its previous string and see if that they are long enough to even have a prefix, B that B is also long enough to have a prefix, and that and see if they're not equal, because if they aren't long enough or they're not equal, that means that we've found the longest prefix. So I was gonna, and we do this max here just in case I is 0. For whatever reason we find no prefix pretty much, and we have to return an empty string. So just run it, see what kind of result we get. Okay, well, we get an empty string for that result, and we get an empty string for this result, which is interesting. We're just gonna console log, just console log everything, I guess. ABI and J. So we're looking at the wrong thing here. This should be I, because that's the character. Okay, so this one should be getting to the L. So I is 2. And J is 2. So we're looking at and then A is O. So we're comparing this O and this I. And we're finding out that they're not equal. Maybe we don't minus 1. Yeah, maybe we don't minus 1. Because we only increment I when we're successful. Okay. So let's see if there's any follow-up. There's no follow-up. So one thing we want to consider is there a way to run this a little bit faster? Let's submit it and see the performance at the moment. If we're really high tiered, then we probably don't have to worry about optimizing. Because we are hitting a time limit somewhere, which means there is an optimization that we could do. Okay, so for the input of an empty string, we exceed the time limit So let's think about that. Okay, so we would never execute this for loop if that were the case. So pretty much we need to add an edge case here. If strings.length equals 0, then we'll return strings sub 0. Just to handle this edge case of there's only one element, so the prefix, it is the prefix. Let's run it just to make sure we're still passing. Let's submit it. Sorry, length is 1. Okay, and we're pretty slow. We're at 2 milliseconds. So we could try to think of some ways to improve it a little bit. So, one thing that comes to mind is maybe not doing this every single time. And this could be just 0. No, yeah, this could be I, this could be 0. I don't think this improves it that much. See if we can think very deeply about this. Usually if you want to try to improve a little bit, you want to try to use like a map or a set or something, some kind of data collection that's a little bit more optimized. You pretty much use some kind of memory to cache some data, but nothing's really coming to me. Because yeah, it's not like we're really looking at anything more than once. And the only way I can really think is to just look at each individual character. Just for the lulz, I guess. See if this helps us at all. Try to index less. There's no way this improves it. So we're beating 42.68%. There's no way we get down to 1 millisecond from just, oh. Interesting. There's a way to get 0 milliseconds though? That's kind of crazy. Well, anyway, it seems that caching is a good way to go. Don't use don't index too many times if you can avoid it. I feel like we could also do this. Then we don't even need to do that anymore, because if we have A, if we don't have A, then we're done. But if we do have A, then we'll have a string with a character in it, which means that if B is null or undefined or whatever, then it will not be equal. So this should also be slightly better performance. Still 1 millisecond though. Okay, well, I actually don't know if we're being compared against other programming languages here. Oh, is this a solution? Will they use recursion? What does this do? What's the slowest? Oh. This is really hard to read. Okay, well. So, this is interesting. We did have this base case in ours. Apparently this JavaScript runs faster than our JavaScript. Prefix 0 sub 0. Turn fn. This value is going to change, which is kind of crazy. In my opinion, you're kind of sacrificing readability for performance, which is usually not ideal. But we try to understand this code anyway. Index prefix.length -1. So kind of working your way backwards. Characters prefix index. It's just getting the last character. And then we're gonna go through the rest of the strings and find character at I, no, the string at I, which is the word. See if the index, okay, so if the index is greater than the word at length, or if the character, okay, so this is like saying, okay, I've kind of given up, I'm done, I found the answer. But it's starting from the back and working its way forward. So it's able to do it, and it's not a match. If index. Ooh. I'm surprised that something like this, doing something like this and doing recursion is more performant than what I did. Ooh. What a doozy. Okay, well, anyway, back to my code. I'm happy with that. So let's go to the problem list. Let's find another easy. Valid parentheses. Now, this is probably one that I've done in college. Given a string s containing these characters, determine if input is valid. Brackets must close the same brackets. Open brackets must be closed in correct order. Every closed bracket has a corresponding bracket. Okay, so yeah, this is pretty standard college question and pretty standard interview question, I would even say. And the solution pretty much you could probably do with recursion, but I think it's easier to do with some kind of a stack. And we'll do something like for let I equals 0, I is less than s dot length, I plus plus, and we'll say const equals s sub I. Alright, get the character, and basically, if this is probably the slow way of doing it. So let's try to optimize prematurely. Opening equals new set. We just want to know all the openings. What we're gonna do is do like const closing equals this, and we'll do just pair it with the corresponding opening. Right? And then we can actually just do object.values of closing here. And then we could say if opening dot has character else. So if it's an opening, then we have to do stack.push character. If we reach the end, then we'll return stack.length is 0. So we want to make sure that we don't have anything extra at the end, that everything has been properly closed off. And finally, we want to, we'll call this closing map, we'll call this opening set, and call this opening set. We'll say closing equals closing map sub character. We'll say const top, we'll say if stack dot pop is not equal to closing, then we'll return false. Pretty much get the top item that we have, see if it's the proper closing tag, and finish it off that way. So we can run it, see what happens. Ah, it should be closing map. Okay, all of them pass. So try to think of ways so we can optimize this before we submit it. But we are using a map, we are using a set. So this should instantly get its result. This should instantly get its result. This should instantly get its result. So it's only as long as this string is in terms of complexity. So I'm already to submit it. See what happens. Okay. We could write something faster. So one thing I would wonder is if looping it differently would be faster. So I wonder if we can do const character of s. Let's run that. And of course, we need to delete that line. Okay, submitting too often, I suppose. Okay. We were at 70.54%, 3 milliseconds. Let's see if this helps at all. It does not. I'm very curious how you can make this faster, but also like readable. Because I think performance is nice and all, but if it's not readable, it doesn't really matter in my opinion. Or if you can't reason or explain. Wow. We have like the exact same code, but their code is faster for some reason. I would have thought that an if like this is going to be slower. Oh wow. This is code. Okay, so this is probably just oh, this is probably just compiled then. That's my guess. I can't imagine that anyone actually wrote that code. And then somehow ours is like just as good as this solution, which hard to reason. This too. It's really hard to reason. So it seems as though their code is faster by not using a set, which is wild. Oh, I'm not gonna push it too much more. I think we're good here. I think I submitted it, right? Yeah. 3 milliseconds. Oh, now it's 4 milliseconds. Unlucky. Okay, let's go to the problems. Let's merge two sorted lists. Sure. This is just merge sort. And the output. Oh, interesting. So we have to create this. So one thing that I'm never really sure of is I think we have to pretend that this is a thing and just use it. We have to make believe. And so, but basically they're both sorted. So we're gonna say so you had the value. I think we need to like merge the two lists into one sorted list. Splicing together the nodes of the first two lists. Return the head of the merged linked list. So the challenge is to return the head, in my opinion. We're gonna have to have like special logic, I think. So we'll do. We'll say const I equals 0. We don't even need that. While list 1. And while list 2. So pretty much the idea that I have is we're gonna go through, we're basically gonna go through all of list 1 until I guess we finish it. In theory, is it possible that we always finish list 1? Probably not. I guess it's possible we finish list 2 first. So we're going to do this initial. We want to set up the head and the current. These are going to be lets. We want to see if list 1.val is less than list 2.val. If it is, then we'll do something. If it's not, we'll do something else. If list 1's val is less than list 2's val, then we need to say that the head equals current equals list 1.val. And then we have to say list 1 equals list 1.next. And then very similar code here, just advance the items. So the head will never change, but the current will. I'm thinking that I'll create a function that like adds to the current. Which would be like current equals current.next equals new list node. I think we actually have to do this. Do it like that. And then we could do this. So current becomes the next thing, which becomes the whatever value we have here. And it's basically the same if condition here. Except we could try to do it in one loop. And rather than continue to change head, we'll just change current. I'll say list one and something like this. And it makes me wonder if there's a way that we can avoid. I mean, now we don't even need that function. Makes me wonder if there's a way to avoid this. I'll just run it to see if this list node variable even exists. That's interesting. I guess we need an or not list too. First. So let's look at the requirements. Okay. The number of nodes in both lists they could both be 0 to 100. Interesting. I'll do not list 2 or I think we'll get another error with this else, but let's just see if they do the edge case. Cannot reval null. Oh, so okay, this is the case where they're both null, I guess. Yeah. This code is gonna be slower. It'll be slower, but I think it'll be more readable. So the output is absolutely wrong. because we're not. Interesting. Okay. Okay, one interesting thing we could do is set these up to be like farce lists. Like we could do this. We could do that. And I think this should actually make a list now. The problem is expected 1, 1. Okay, well, we got just 4. I guess what we could do is do console logs of current and head and see what we get. So 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 4. Does that make sense? So, well, head should not be changing. Why did I write that? Let's run that. Okay, this is better. This is because we added that fake value. They start off like this. So we just gotta skip to the next one. Now, again, I don't think this is as efficient because of this extra line here. Do I even need to do this anymore? I don't actually think so. Since we have this. So then the question becomes, is there another thing we could do to improve performance? It seems unlikely. Pretty much keep doing it as long as we have a list to do, to process. If there's not a list to, then we'll just use list 1. Or if list 1 and the comparison leads us down here, then we'll do that. Otherwise, basically we'll go down here. This one will prevent us from going down here by accident. And if these were both false, then we wouldn't have gone in this while loop in the first place. So I'm going to submit it and see where we're at in terms of performance. Okay, well, I guess no one's really done this. I'm kind of surprised. 100% is kind of wild to me. Let's see what other solutions people have gotten. Okay, so they actually... Oh, that's really interesting. That's really smart. That's so smart. Because it's a linked list, they're able to just complete it by using the reference to the previous linked list. That's really smart. I don't know how theirs is not more performant than mine then. Because their conditions are also simpler. This is much simpler. That's really cool. And otherwise they did very similar solution. Let's look at some of the slower solutions. Okay, this seems to be a very common theme. Oh, they did the same thing. Why didn't I think of this? Oh, this is why we practice. Okay. I did 3 easies, so let's do 3 mediums. Okay, longest palindromic string. So we're given an S, and we return the longest palindromic string, which is a string that's the same forward as it is backwards. This is a medium. This is actually pretty challenging. It's not like intuitive. Good evening to cast. Yes. The cast. How's it going? ABA is also valid. I'm doing alright. Surviving. Just trying to pass the time. Yes, I have an interview tomorrow. Tomorrow afternoon. At Camo, I could use ChatGPT, but I'm trying to avoid using AI. I really want to think about it, because I'm thinking about interviews, and during the interview, I feel like it's kind of a dev work already or breaking into the field. I recently just got I got let go from my previous job about a week ago, so I'm just trying to find something new. Let's do it without GPT. Let's do it. Computer science student. Nice. 4th semester. If I'm reading that correctly. Awesome. Yeah, LeetCode is really good for sharpening your skills. But yeah, it's been a while since I've dived into LeetCode. I have like 10 years experience in the field, so it's been a while. Companies don't really do traditional LeetCode anymore. They do more practical coding, especially if you do like UI experiences. So they usually ask you to build like actual programs or websites and whatnot. But sometimes you get surprise old school LeetCode challenges. It's good to be able to think through them. Have any advice? So usually my go-to strategy is to be able to think in parallel while you solve a problem. So for example, I I think it's always better to get a solution really quick, even if it's bad, if it's slow. Get the solution super quick. Because this one, it is possible. You can say like, let longest seen so far is an empty string, and we could just return longest seen so far. And basically you could just do a very naive, very basic solution that just gets an answer on the paper, because I think that that's the most important thing. Is you don't want to struggle getting the perfect solution right away, because you end up not getting a solution at all, and that seems to me to be anticlimactic. So I think it's better to just think of, even if it's n squared, n cubed, n to the n, no matter how bad the complexity is, get an answer on the paper, get an answer on the whiteboard, get an answer in code. And then while you're writing that, you could kind of start thinking, okay, how would I actually do this? And even when you're done, you can see like, oh, this is a pattern I've seen before, and this is how I would apply this other pattern to improve the performance. So I'm gonna go with like a really naive solution, probably like an n squared solution, and it's probably not even gonna be correct. But I think that I would want to try to get something on the paper first, just so I can reason why it's challenging, I guess. So probably one thing, this is also a medium challenge, so like it's surprising that it's this complicated. But we could do return false. Actually return true. We're trying to find like an exception. If we're doing a palindrome function here, we do let I equals 0, I is less than input dot length divided by 2, I plus plus. If input sub I is not equal to input sub I, input dot length minus I minus 1. So yeah, my intuition tells me make this palindrome function. This is progress. You know, it's good to show that you at least kind of understand the problem. When you try to solve a problem in LeetCode, sometimes it took me hours. I don't know. Always end up getting help from GPT. I mean that's okay early on, because it's hard to recognize patterns early on, and the more problems you see, the more problems you solve, the better you get at recognizing the patterns and recognizing the language, like the art of converting like product requirements into code. But it's really good to take things step by step, or to like even draw out the process before you actually code it. So one thing that we could try to do is basically like try to make every single substring we could think of. And j will be I plus 1. Actually plus 2, because actually it's fine, we'll do 1. It could be part of the optimization when we hit it. And j is less than s dot length, j plus plus. And basically we would say like s substring equals s dot substring from I to j. Basically, like we're gonna be going through each index of the string, and then building all the different substrings that we can from the string. And yeah, it's a horrible idea, but will it work is the real question. And then we can worry about optimization. And so the other thing, what do we need to return? We have to return the string, as we've determined already. So we want to see if it's a palindrome. Actually, we don't even care. We don't want to run the palindrome code unless it is actually going to be bigger. So if the length is bigger than longest seen so far, that length, and at the palindrome, then we'll say longest seen so far equals substring. And we'll just change the order of this and spell that correctly. So yeah, we have this code that determines if a string is a palindrome. Hopefully it's correct. And then we go through this string and make every single substring we can with that string and see if we can find a palindrome longer than that. How we can run it, just see, we'll probably get an error. Luckily we can just run it. We're not in TypeScript land, so we can't do that. And we do get a valid, we do have a valid solution, but we can think of ways to improve it. I mean, let's just submit it and see how we're doing against the rest of the world. Okay, well, we don't even pass through all the tests. So we could try to think about why that might be the case. The input is just the string A. So it's probably gonna be this. Seems so. Okay, so we're not going into the inner loop because I think we have to allow it to go to the end here to get every single substring. And the reason for that is because if it is a length 0, and then we do I is 0, j is I plus 1, I plus 1 would be 0 plus 1 is 1. And then we'll see if 1 is less than 1, which would have been false. So I think we have to do equals to, especially because we're doing a substring, we got to put the ending index of the substring, and that should be the length. So let's submit that. Okay. So at some point BB happens. So one thing that we could do is just make sure we're doing all the substrings, potentially. So let's just run this, look at the output, make sure we're doing every single substring. So BA, BAB, BAB. Okay, and then it should be AB, AB. There's more. We'll do a console log here, just so that we can say when I is changing. Ideally, these should be shorter and shorter. Right. It seems like we're not getting all the way to the end, which makes me think I don't know how substring function works. It is the end index, not the length. This is interesting though. I don't know why these both look the same. They get less and less, which is expected. But I don't understand why it's AD AD. I feel like it should be, or even this one is BAD. I feel like it should be, it should just be B, then BA, then BAD. Substring. It is a length. Oh my gosh. Okay, so apparently, I guess I'm calling the wrong function. If you can imagine. Let's take a look. Alright, that's what I was expecting. So, we're able to get some logging in there. And I think we could try to submit it again. Okay, so we did horrible, but that's okay because we got it. We got a solution. Now this is medium difficulty, so I'm surprised that it is as hard as it is. I would have thought this would be hard. My instinct tells me that right now we're at like an n squared and cube algorithm. My instinct tells me we could probably do this with like dynamic programming or recursion. But it's important that we got a solution. Or we could try to think, how can we make it faster? Okay, we're at 426 milliseconds. So one idea that I have is do start n. We'll say start. This is still I. End minus start divided by 2. And this will be end. And basically, rather than making a substring here, we are going to pass in new arguments. And we'll say length equals j minus I. Put that there. And then we'll say s dot substring I sub j. Only make the substring if we have to. So it's a little expensive to make a substring. Just a little bit. I mean, in theory, we could also I wish we could just return the length. We'll do this. Length equals 0. And rather than do substring here, we'll also do, again, because it's expensive, just make a list, create a second list, reverse, compare the two, counting if they match. So I keep it till it breaks, start counting again. That's an interesting idea. You could definitely add, you could definitely give your own ideas. In terms of having a forward and backward version, I mean, we could just look at the end of the array rather than make like a clone of it. So, like, I guess you can, in theory, have a virtual reverse list by just looking at the list backwards, using indices. I just want to kind of go hard with this idea of trying to optimize what we have here as best we can. Until, so we're at, let's see if this works. We're at 426, 19%. Okay, that's okay. Substring's not, yes, it's not. This should be yes. Run it. Okay. So we'll do a log there. I think the other thing is it's not just about counting, unfortunately. 1 to 5. 0 to 3. We could do this for now, just for logging. Let's just make sure that what we're seeing are actual palindromes, because I'm wondering if if our palindrome code is wrong now. This is not a palindrome. So is it? No, it's not the same thing forward as it is backwards. N minus I minus 1. I is start, I is less than half. Half is n minus start, divided by 2. Oh. I'm missing something here. I need to add start back on, because this is just getting the length, dividing that length by 2, and then we have to offset it by where we're starting, so that we don't stop early. We're actually stopping early at the moment. But it's still giving bad output. BAB is correct. BAB is also correct. ABAD is not correct. And somehow, oh, well, BAD is not correct. What am I talking about? So let's also output, I don't know, let's output I, let's output J, and then we could think about why it thinks those are correct. BAB03. Well, BAB is correct. Well, BAD is 25. So let's run this manually. So it's BAD 25. Actually, it's not BAD. It's this string. And 0, 1, 2. That's yep. And then 5. Yep. So let's think about this. What is the value of half? It's going to be 5 minus 2 is 3. 3 divided by 2 is 1.5. Plus 1.5 plus 2 is 3.5. Okay? Now, I equals start. I equals 2. But half equals 3.5. Okay, so input sub I is 2. So 0, 1, 2 is B. If B is not equal to end is 5. 5 minus I. Ooh, interesting. We can't minus I anymore. Or we can't, if I starts at start, we can't minus I. Okay. Okay, so maybe this is 0. This is that. And this is start plus I. And this is end minus I minus 1. Okay, let's go through it all again. So half is 1.5. I is 0. Great. So input start sub I. Start is 2. I is 0, so it's 2, which is B. Is not equal to end, which is 5, minus I, which is 0, minus 1, which is 1, which is 4, which would give us the D, and then it would make it, it would see that it's not equal, and then evaluate that correctly. Okay, so let's run it now. Okay, our second case is failing now. Output is empty string expected BB. Okay. So let's go back to console logging this, and then we'll run it again. Are we hitting BB? That's the wrong case. No, that's the right case. Are we showing BB? BB is here. So we'll go to BB, and we're giving it CBBD. CBBD. And then the BB is 1, 3. Um, 0, 1, 2, 3. I'm a little curious about that. It seems like it's exclusive. I feel like it should be 1, 2, not 1, 3. CBBD. Oh, because substring is it's sub is it substring? Substra? Oh my gosh, it's substring. Okay. BB. I swear it should be 1, 2 though. Substring. The index is not included. Okay, the index is not included. Fine. Okay, so it should be 1, 3. Okay, back on track. Let's do it. Let's run the code. For some reason this is getting a false. So start is 1. End is 3. So 3 minus, let's clear this out. End minus start, 3 minus 1 is 2. Divided by 2 is 1. Okay. I is 0. Okay. It's I less than half. Half is 1, so yes, I is less than half. So start is 1. So, or sorry, start is 1 plus 0 is 1, so we get the B. We get the B on the left. And then end is 3 minus 0 minus 1 is 2. So we get the B. So yeah, that seems correct. So are we going into this then? Oh, this is not correct. Okay. Okay. Alright, we were at 426, 20%. Let's see if we did any better. Okay, we halved it, which is pretty good. We halved it by basically not doing a substring every time. So the question is, can we do even better than that? So part of me thinks we could get it a little bit better, even more so by figuring out early exits. Basically, if we did minus this, there's no point of continuing any longer. Like if we're on the last few characters and those characters are not enough to beat our longest scene so far, then we can exit early. So we're at 218. See if we do any better. Early exit. Barely better. As at this point where we gotta kind of come to the realization that it's our algorithm that's the issue and not an optimization with the algorithm, if we're this far away from the solution. So my first instinct is it's probably like a dynamic programming problem. Something to where you like create a table. Or even do recursion. I think recursion is an interesting idea. Is there a way to like save this? we'll do const old solution. Okay, so I have essentially two ideas in my mind. One is some kind of dynamic programming solution, and the other is recursion. Basically, what we want to do is try to splice the palindrome check in with the changing of the substringing, and try to do them both at once, and essentially like keep expanding. Something to the effect of, okay, here's my idea. Assume every character is a palindrome, and start from there and work your way out. Something like that. So look at each character and expand out until it's like no longer a palindrome. To some extent, I kind of wonder yeah, there's got to be like something to where S start end, right? And then we got to do like S dot map character index. And then we'll find we'll dot sort it. Maybe a b dot length minus a dot length. No, that's horrible. That's just lazy. Dot reduce max. We're palindrome, and then we'll do this needs to be expand. S index plus 1. Basically, like I said, we assume that every character is already a palindrome. I'll say max dot length is greater than is less than palindrome dot length. Then sure we're spelling this correct. Palindrome, palindrome. Otherwise it's max. Something like that. And then the first string is going to be the default. But basically, we'll do like different kinds of expansions. We'll say left only is a -1 for the start. Right only is +1 to the end. And then both. Something like that. Basically starting at a character and expanding out. We could do, actually we could do if s sub start is not equal to s sub end -1, turn empty array. Return oh, it's a little complicated. I want to try to avoid substringing if possible. To keep it simple for now, I will just substring. And then we'll expand s start end. Something like this. The only question is, how do you stop it from going infinite? Well, it never takes in less characters. It never unexpands, so hopefully the fact that that's the case isn't too bad. Let's run it. Check it. We gotta do a split of all the characters by empty. We'll do a flat map. Okay. Okay, we have a bunch of palindromes, that's for sure. And can I make this better? Can I not substring? We'll do this as an object. Okay, great. A is max dot end minus max dot start. B equals max dot palindrome dot end minus palindrome. It's not really a palindrome, but it's fine. Dot end. Return A greater than B. A, B. And then we'll return s dot substring of max dot start max dot end. Let's do a console log of results. Is it substring or substring? String. It's so confusing. Okay. I guess we could do n minus start, n minus start, map it, s dot substring. Don't actually use the character, which is fine. See what this looks like. Okay, and I guess let's see what max looks like. Yep. Okay, 0, 1. So max A and B. Max, palindrome. I just make sure every A, B has a value. It does. Okay, it seems to think everything's length is 1. Oops. That'll do it. Okay. Let's clear up some of these logs. Run that, make sure there's no logs. Okay, We were at 211 milliseconds. Let's submit it. Oh gosh, it doesn't feel like it would be faster. Dang. Okay. We're gonna do if end is greater than s.length or start is less than 0. We also return empty array. Don't go out of bounds. ACAA. Darn. So we're saying that that is a oh, that's the problem. If I feel like I should only be able to go left one or right one. Yeah, I should only be able to go left one or right one if n minus start equals 1. Otherwise I have to work outwards. So if it's length 1, then I can try to do like a palindrome of length 2. If it's not equal to 1, then I can only keep expanding 2 at a time. That's my understanding, and that's because I probably start with these 3, I expand out 1 to the right, and then I match to the left, and it's like, yeah, that's a match, it's a palindrome. So okay, in my opinion, there's no way this will ever be faster than the code that I had. Which tells me that there's an even better solution. Okay, I think I know when to admit defeat here. So we're just gonna return old solution of S here. Optimize question mark, submit it. Okay, and now I will just cheat and see what the best solution looks like. Wow. Interesting. They definitely do a nested for loop. And they definitely call it is palindrome. How is this run faster than mine? What? They even slice. How is this run faster than my code? If not, set has substring, set add substring. If they, oh my gosh. How is theirs faster than mine? What on earth is this? Are they trying to do like a regex? Let's see. This is okay. This is kind of crazy looking. So it looks like they're trying to do some crazy regex. Okay, so s dot length array 2 times n plus 3. Fill it with zeros. T sub 0 is the caret. The last thing is the dollar. The second to last thing is a hash. Go through each item. Add hashes everywhere. Wow. Oh my god. What is this monstrosity? Wow. Okay, so this one had a similar idea to me. They had very similar ideas to me. Okay, I don't feel so bad because like I have code that should run faster than their code. I'm confused why it doesn't. Okay, well, we did optimize. Our solution is runs at twice the speed as when we started, so I'm gonna count that as a win. Let's do another medium. Okay. Return x where digits reverse. Reversing x causes the value to go outside the sign. Then return 0. Oh my gosh. Okay. Assume the environment doesn't allow you to store. Okay. Compared to the last one, this one should be pretty easy. Const output equals 0 while x. So we're pretty much going to be output equals output times 10 plus x mod 10. Basically, we're getting the ones digit off of x, adding it to the output while pushing the current ones digit over 1. And then we say x divide equals 10. We'll do we'll floor it every time, and then return output greater than 0, out greater than 0, output else 0. I think that's what they're saying to do. This is a const. Oh, that's interesting. Okay, that's not, so this isn't, I guess that's not what they said. I'll get the sign, which is just x divided by math.abs of x, and then we'll say x equals sign times x. And want it within this range. All right, I'm just gonna do this for now. And then we gotta multiply by sign. And I guess we could just submit it. If there's this edge case, I don't really care about it. But if we have to care about it, then fine. Interesting. Ooh. It's fine. We didn't handle the edge case of x being 0, so 0 divided by 0 was problematic. Alright. We want to figure out if I don't know. What is it? What's the description? Bound equals math.pow 2 to the 31. If do return negative bound less than equal to, and output is less than or equal to bound minus 1. Submit. Wow, we did horrible. Interesting. Okay. Oh, I'm very curious if there's like a big O1 to do this. And this graph is interesting too, like how most people just suddenly get it. 61 milliseconds, that's crazy. Okay. So skip this one. I think it's more complicated to put a. It'd be slower to put a more complex condition here. Is there like a math.sign function? Interesting, there is. Well, what's the math.sign? 0 is 0. Which is fine. I don't think this helps very much. I mean, 61. Oh, it helped a little bit. I'm curious how expensive 4 is. $56, $52. So this is just double tilde, which is just like it knots it and then knots it again, which in terms of JavaScript just makes it drop the decimals. Doesn't necessarily floor it, I think it just drops decimals. Which in that case makes me wonder if we can get rid of that. Wait. What? We don't even need that? That's crazy. All right, 52 becomes 53 somehow. Okay, I mean, if I were to imagine a potentially better way, which I can't really imagine how it could be better, it's just like turning it into a string and reversing it. I don't know if there's another way to get the ones and to push this over and to mark this as processed. Let's look. Let's see what the best solution is. How is this faster? How? That makes no sense. Yeah, but they turn it to a string first. How is this faster than my solution? Okay, back to my code. Is this faster? $53. No, it's even slower. Okay. Well, I mean, we have the best code. It just doesn't run faster than anyone else's. It's less code. It's more readable, but it's slower somehow. A little confused, but let's go to the problems. I think that's 3 mediums. We did the reverse. We did palindromic. Thought we did 2. I thought we did 3. At any rate, it'd probably be good to do a hard one and then call it. Alright, given 2 sorted arrays, size m and n, return the median of the 2 sorted arrays. It's gotta be big O log mn. It's gotta be log mn. Okay. Although, okay, it is an array of numbers at least. Okay, it's not terribly difficult. It's important to know what the median is though. So the middle is dot length. What do we do if it's odd? Which is 3 divided by 2 floored 1. Okay. 2 dot length divided by 2. They go together. Math dot floor. All right, that's the middle. So we'll have a left, which is 0. We'll have a right, which is 0, and we'll have an index, which is 0. And basically, while index is less than middle, we're gonna keep looping. And I guess these are all lets. just do while true. If index, no. And then while true, if nums 1 sub left less than nums 2 sub right. So if it's less than, so we have to increase the left. Else right plus plus. I think we gotta do this magical formula. If there's not a second one, then we do this. And then the index increases. And then we do if index equals middle, return nums sub 1, nums 1 sub left. Right. Something like that. I'm probably off by 1. Yeah, I'm off by 1. Maybe it's this. Wait, what? Oh. Oh, no way. Okay, that makes it a little bit harder. Previous equals there is no previous. Previous is nums 1 left. Two right. Okay. Let's just do this. And we'll do found dot push nums 1 sub left. And then we'll do while found dot length is less than middle. Don't floor it. Earn bound sub middle. Alright, let's just run that. We don't even need index anymore. We don't even need previous. Let's just get one of them correct. That's an equal to. Cool. And let's do that. Right. And so I think we gotta do it's gonna be length mod 2 equals 0. If it's even, then we do found sub middle plus found sub middle minus 1 divided by 2. Okay, let's submit it and see how we did. Got not a number. We can close this, give us more space. Okay. So this should be taking 0 plus 0. I think the middle is gonna be 2. Let's do this. So we are getting undefined. Let's just double check all of this. So it seems like we're trying to push like left or right. Submit that. See which condition is going down. It's going down left. Ah. Um, we'll do that. No, not. Okay, if right is out of bound, if left is inbounds. Okay, that should give us a better result. Wow, we actually did well. 1 millisecond. Okay, so the question is, how do we make it better? I feel like push is kind of slow. But better than 99.35% is pretty good. But if I were to optimize, I would imagine that if we did like current, previous, and then here we could say previous equals current. And then we can get rid of found. We're gonna need an index. This will be current. Current plus previous. Make sure that we didn't miss a variable. This is index. Run it. This might need to change to less than. Okay. Do console log current previous length. See what we get out of that. Undefined, undefined. Interesting. I'm surprised that current would be undefined. Unless, yes. Yeah, wait, what did I have? Yeah, index is less than or equal to middle. Okay. Middle, okay, so index not defined, which is understandable. Okay, so we no longer have an array. All right, let's submit it. We're at 1 millisecond, 99.35. Wow. Okay, we must have gotten lucky that first run. Because there's no way that this is like that much worse. Wow. A apparently, I feel like for large numbers, the array is going to be, I mean, it's going to take up way more memory. Like, it's only concerned about time complexity. It's not concerned about memory complexity. So I think this algorithm is much better. As the big O of memory complexity is 1. Okay. I think that's gonna be it for today. We did a few easies, a few mediums, and a few hards. I'll likely do more some other time later this week, but yeah, that was fun. I hope you learned something. Thanks for joining, everyone. Bye for now.